Hey fellow devs, I wanted to expand my AI state tree to support different movement behaviors when mobs are trying to use an ability. Rather than implementing the behaviors explicitly around handling range, targeting, and etc. inside this one massive state tree, I found a method to use add LinkedStateTreeOverrides in the state tree component during runtime. This allows me to change these state trees that are linked into here and to allow my mobs to do different types of behaviors for the different chosen abilities they want to use. Reminder, this is just a quick showcase on how I got this setup working for my project. This is similar to the Lords of the Fallen, where they talked about a similar structure with different kind of behavior trees encapsulating their behaviors. But for my purposes, I kept everything inside of a state tree, with state trees linking into other state trees instead of behavior trees. So a lot of the data architecture is set up inside these data assets for each of my AI. And right here, you can see all the ability information. It's ability way to pretty much have a chance to choose this ability versus the others. There's some range, the targeting, and the state tree that gets linked. So you see here for this kind of shaman type, we have a cold blast and earth stomp, both with different types of behaviors. And then for here we have a rat with a different type of behavior for a bite with a low range. And here we have a wasp that also does like something unique where it moves around before casting its ability. So now that you know the architecture of the data, when we choose the ability, it's pretty much going to go inside the bot pond data, find the correct asset that it wants to choose for its ability, and then add it to the linked state tree. And so how that's being done is that I wrote a task. This is the wait until viable ability. And so in here, this is the task for the C++ implementation. I choose some sort of like waiting system to choose the ability. But when I actually find it and set it up, this is the actual meat of the code that adds the linked state tree override, sets up the right parameters, and then puts it into the state tree component. Now, an important line to take note of is this chosen ability info, where I set some sort of information that's actually just all the information inside of here minus the state tree. So it's pretty much just the cast range and the result of this choose target type, which is most likely just some actor, pretty much like the current player that we want to hit. And so in these actual state trees that get linked, I have this one that moves around the target and gets in range, like for the wasp. And all of them have the same evaluator. So I'm going to go through all the other ones, and they each have the same evaluator that pretty much gets the ability info that was enacted, like the chosen ability, the range, and the target. And so each of these have a different implementation. I'll go inside this one, for example. So this one allows me to move around a random target, around a random location of the target, and then proceed to move in range, and then activate the ability. This one requires me to wait until facing before proceeding, which is very useful for instant casting abilities. And then this one is just a simple move in range, no checks of facing angle. So that is pretty much it for the entire system as a brief overview. I'm pretty happy with the results, and I like all the different modular behaviors and ways I can implement different kind of movements and targeting while not having to like completely reinvent the wheel on how these abilities work internally. So yeah, I hope you enjoyed this and learned something. I'm sorry if it's a little brief, but I hope you can at least get an idea of how to apply this for your own project. Anyway, thanks for watching.